Nate, the world is an interesting place right now, full of conflict. With all the conflict happening, the war zones around the world, how are you and the team at Shield AI thinking about autonomy?
Yeah, it's a great question, and thanks for meeting with me today. Um, the the need for autonomy and intelligent systems has grown tremendously. The ability to deploy systems into conflict, into dangerous areas where human life is put at risk, it is obviously clear. And the ability to have systems that can think for themselves and really impact the mission in a favorable manner is also abundantly clear. So right now at Shield AI, we're really thinking about how do we bring our autonomy capabilities, which we call Hivemind, to a variety of different platforms across different domains and different mission sets in order to both support the US and its partners and allies in order to impact the mission.
If you look at the United States and our allies around the world, if you Department of War here in the United States under Secretary Hagstaff has been very pro autonomy. Are you getting that same pro autonomy reception from allies of the United States?
Yeah, absolutely. I think with what you're seeing in or have seen in Ukraine, what you're seeing now in Iran, what you're seeing in other conflict areas, is that these types of systems create significant um, opportunity and are at a point where they can truly impact and create asymmetric advantage in a few different ways. And so we are absolutely seeing across the globe a clear statement that autonomy is necessary and it is a huge enabler for the future fight.
If you're looking at some of the very public examples of autonomy being deployed in combat today are drones. And if you look back at history, one of the great wins of for what Patton did with the tanks in World War II is drones becoming the modern warfare's equivalent of the Abrams tank.
I think that's one way to look at it. I mean, the advantage of drones really is that you can create at this moment significant um, asymmetry in terms of cost and impact. So basically, price per effect or outcome. And you can do that at an offset or a reach that makes it possible to not need to bring people into combat in the same way that would have been in the past. On top of that, it's possible to now produce drones at scale of different types and different capabilities. And in particular, as you start to look at more of the larger scale or exquisite capabilities, so thinking more towards sort of uncrewed fighter jets or similar, you're really starting to get into a place where you can deliver incredible effects and outcomes, again, without requiring the need to put human and pilots into those situations.
This is asking you to look at a crystal ball, but if you fast forward to a point in the future, does most of the modern warfare from an aerial perspective become autonomous without putting human life at risk?
Yeah, I think that the future is one that is going to be driven by AI and robotics. It is going to be software defined platforms. I mean, we'll always keep humans in and on the loop in order to be able to collaborate, to make decisions, and to engage with that system. Over time, we'll grow more and more trusting of the systems in terms of their capabilities as we better understand their performance in an engineered manner. But it's definitely the case that as we look toward the future, we are moving to autonomous systems engaging in combat. It'll really change the face of how we approach these types of operations and combat conditions.
Do you think society's ready for that?
I think that the short answer is yes and no. Yes, in the sense that we're seeing it already, and society is seeing the impact that is being made. I think that the news reports coming out of Ukraine, coming out of Iran, and that conflict all indicates that drones are being used extensively throughout these types of operations. Ukraine is probably the one notable one where the clear impact of drones and the way that has enabled Ukraine to kind of change the balance of the conflict is well understood. Now, with that said, the technology and what technologies we're using and how those technologies are regulated how they are understood from a verification and validation perspective, from an engineering lens, how we assure performance. Those are all topics where, while we're making progress, not there aren't necessarily guidelines across the board. And so it's certainly the case that, for example, in the US, the DOW is pulling those types of guidelines together. And certainly the case that other countries are doing the same. But it's still in the early days. It's still nascent. And I think there's going to be a lot of learning in terms of how do you use these new technologies? How do we want to govern them? How do we want to ensure that they behave as expected and perform? So I think there's a balance here where society is getting exposure to the use of these technologies in conflict and the meaningful impact that can be made. Governments are understanding or starting to understand and articulate what are the right ways to regulate and apply these technologies. But we still have work to do as we are developing it at the same time.
I would think that's a very balanced, fair, measured approach, and I believe that the future of warfare is autonomous. And when it truly has a tipping point, I don't know, but I believe at some point it's going to come. If you go back to the early days prior to you joining Shield AI, you were developing the Hivemind model. How, over your journey of developing that model, how has it changed? How has it evolved? And what were some of the big technical breakthroughs where you looked at yourself and said, all right, all right, all right, I did it, I achieved it?
Yeah, it's a great question. So, as you noted, I've been working in AI and robotics for a long time now, more than 20 years. And before Shield AI ever existed, I was, even up until about 3 years ago, as a professor in the Robotics Institute at Carnegie Mellon University. And we were building out these types of edge level intelligence, resilient intelligence capabilities that were running on a number of different platforms in the air, on the ground, in water, and similar. The big gap with Shield AI, or the big step with Shield AI, was really making it possible to take that type of technology, those kinds of approaches, and both scale them and operationalize them and have them make impact. And so that was a big part of joining and working with Shield AI in the early days. And now we've scaled it at a global level. It's being deployed on 30 plus platforms at this point across air, moving into sea, and even space at this time. Now, to your question of were there any aha moments? I think in the early days, I remember very concretely back in summer of 2017, presenting to the team, this is what Hivemind is, this is what it will be, this is what we're building. And we built it and applied it to smaller aircraft, so quadcopters, as our first platforms. And then we extended that to slightly larger air vehicles and even larger air vehicles. And at the same time built out this platform that made it possible to then take it and apply it to new classes of systems, new domains very, very rapidly. And so in terms of the key aha moments, I would say, first, there was this statement or this hypothesis that it's possible to build this type of architecture that in general applies across all different types of platforms and domains and mission sets. And it is possible to create the tools that allow you to really specialize those capabilities and drive toward concepts of quality control, quality assurance within the context of autonomy and intelligent systems. I would say the aha moments kind of came unsurprisingly along the way as technology advanced. We had fairly sophisticated, or I would claim quite sophisticated techniques that just continued to advance and improve. I think that we leverage everything that you would imagine in terms of different traditional autonomy algorithms and implementations to state-of-the-art AI techniques. We have to be very thoughtful about what we use and how we use it. We have to achieve certain levels of performance guarantees and be able to provide certain thresholds and bounds. So we have to be very selective in our techniques. But I think the aha moment was less about the tech and more about having the business organized, operationalized, and able to scale and engage with the customers in order to be able to make that impact. I would say of everything, that was the hardest part, is getting ourselves into a place where we were structured as a business and as a company overall to be able to really bring this to the globe, bring this to customers, not just help them understand what we're doing, but move quickly to just deliver outcomes and impact for them. And that's really what mattered. So I think getting that into the right place was the big lift, I would say. I think that the tech part was certainly hard and interesting, and maybe that's because this is my area where I'm really focused. but getting the business to a place where we could go through the full motion to get to a place where we could really step out there with the customer, understand what they wanted, deliver that value, and in days, if not weeks, achieve outcomes. That was a big moment, I would say. I think recently there was an example where we were asked to contribute within the context of Ukraine. We were brought in within 48 hours. We had Hivemind integrated on a platform. And within 2 weeks, we were running missions and operations and having effects where likelihood of success went from about 5% to about 75%. And that's a meaningful impact and outcome. And so that type of game change, I would say, really was an aha moment of, yes, we got there, we achieved the goal.
I say this a lot. You can build the world's greatest mousetrap, but without the business to power it, doesn't matter. It doesn't go anywhere. There's just there in language. And in my opinion, looking at this from the outside and reviewing your public documentation, it seems that Shield AI has both the technical prowess and the business prowess, and it's clearly showing in your fundraising rounds. I'm curious, on the Ukraine front, the XBAT, you deployed that, BAT, you deployed that there. Was that the vehicle that you were referencing, or was this something else?
No. So first, just to clarify, the VBAT is our more medium-sized intelligence, surveillance, and reconnaissance platform. The VBAT is what we deployed in Ukraine and have been doing so for the last 2 to 3 years. The XBAT is our uncrewed autonomous strike fighter that we're in the process of building. But to your question on the VBAT, we actually we deployed the VBAT starting about 2 years ago. It's been in consistent use, really delivering important effects and outcomes, and we're regularly getting feedback from the Ukrainians that it's helping them in their pursuit. We integrated Hivemind on the VBAT to support that. The way that the VBAT is designed with Hivemind on board is really it's designed to operate in degraded and denied conditions. So think of that as places where GPS is either jammed or spoofed, communications may or may not be available. And so now by putting Hivemind onto that platform, the VBAT, it's able to go out and engage in ISR, reconnaissance, and surveillance in particular, in order to be able to support different mission sets, provide feedback, and operational awareness, amongst other things. Now, the example I gave a moment ago where we integrated onto a platform, that was actually a one-way attack drone, where we integrated Hivemind onto that one-way attack drone, now making it possible for it to achieve far superior likelihood of success. So the idea there is when you send out these low-cost systems, they have specific mission sets that they're executing, and in general, maybe 1 out of every 10 or more likely 1 out of every 20 actually achieve the desired effect. And that changed dramatically, as I noted a moment ago, when we integrated Hivemind on board, because the intelligence is able to offset a lot of the challenges and issues that caused a loss of mission efficacy otherwise.
Hivemind was the accelerant to success. Would you describe it that way?
I would say is it the accelerant? I think it's more of, it was the necessary intelligence required to operate in those types of challenging conditions. And without putting that intelligence on board and giving the platform a brain that could really think, the conditions and the environment were hard enough that it just wasn't possible for those platforms to be successful.
Fascinating. So how do you adapt Hivemind to the different, if you want to term, aircraft or vehicle formats that you're publicly operating on?
Sure. So first, Hivemind is think of it as sort of like an ecosystem or a framework. There's our pilot, which we can put, that's the edge level intelligence that runs on the systems themselves. But there's an entire autonomy factory that backs it, that is really used to go from the design phases. So think of that as designing the scenarios, the mission sets, and then going into designing the intelligence stack, testing, verifying, iterating, and improving on that. And so Hivemind itself is both what's running on the system, that's the Hivemind pilot, that's our AI pilot, as well as that full ecosystem that allows you to specialize for that particular mission set and need. Very early on, we recognized that for our particular domain, we have platforms that change regularly based on mission need. You have, of course, missions that can be highly varied, and they can change hour by hour, not just day by day. And you have different environment and context, and you need to be able to do this across different domains. So from the beginning, we architected a system that would be able to support that. So where you have self-driving vehicles that largely go from point A to point B, and their job is to make sure that it's done safely and correctly without injury or risk, and transporting one thing from point A to point B. Our mission sets are that and vastly more. We have to range from being able to support different types of coordination and reconnaissance and intelligence gathering to certain types of effects and outcomes, like I was describing a moment ago in Ukraine, to exploring underground tunnel networks. So there are many different things that we have to be able to support in terms of diverse mission sets. And so we designed this framework as much recognizing that the ability to very efficiently and effectively adapt is as important as the intelligence stack itself, if not more. And the ability to do that in an automated manner or a streamlined manner that allows you to also build in quality assurance, quality control, test verification, traceability, auditability, all of those types of factors that allow for you to have a degree of assurance and confidence and performance. That is all super critical. And you would have to be able to do that very, very quickly. So we built from the beginning an architecture and a framework that really accommodated that. And then over time, actually took that and productized that so that not only we could use it, but our customers could also use it. And so now when you're stepping up to an entirely new platform, so for example, we publicly announced that we were working with Huntington Ingalls, HII, integrating Hivemind onto their platform. We announced that early September of last year. We were in the field testing on their platform by the first or second week of October. And so that gives you an idea of deploying on our first maritime vessel and getting to tests in the water that quickly. The basic approach is one where you specialize through changes in or through configuration and plugins and support for different classes of models. But the framework is able to accommodate those, and then the overall autonomy factory is able to iterate rapidly in order to be able to specialize to those new vehicle capabilities, those new sensing capabilities, perhaps the changes in compute and similar considerations that are available, and even the change in the domain.
Fascinating. So you go from air to sea. Did you have to gather maritime specific data to train any part of Hivemind for that environment?
Sure. We had to introduce changes to the underlying sensor models, changes to the underlying vehicle models, obviously. The physics of that environment changed, so we had to take that into account through simulation and synthetic data generation. Those were all things that we needed to do, but that's pretty straightforward to do within our framework. So we introduced those, and then shortly thereafter, that was the harder part of it. Once we did that, then within a few days, we had AI pilots that could work within that context to be able to run those mission sets. And then you go into the phase of deployment, integration and deployment onto the platforms themselves. And because we've also had to build all of that out in the framework, that was pretty straightforward. So it's more or less those are the sequence of events that have to happen. And once you do that, then you're able to get straight to test. Then you can take the real world data, feed that back in, and kind of bridge from simulation to reality, and from reality back to simulation to improve the performance.
I have to put on my sailor curiosity hat here. Tides and currents. How do you account for that change?
So I would say right now, for the mission sets and what we've been doing, we haven't really been accounting for it. And the simple answer is because we are still deploying on these maritime vessels in sort of like a lower maturity state. I would say for the mission sets where we're actually in operations for the air domain, that is where we have to account for all of those complexities that can emerge. I would say that things like tides, currents, there are a number of other factors, changes in sea state and meaningful impacts to how sensors perform. There's a certain level of fidelity. We just haven't gotten there yet. And so the simple answer is we haven't crossed that. And as we get closer to operationalizing the capability, we will.
That's fascinating. would you say that maritime, if you want to say, is a growth market for Shield or an exploratory market? How would you categorize that?
I would call it a growth market, and the same with space. Our pedigree and our background is predominantly in the air domain, and now we are expanding into maritime and space.
If you stay, before we get into space, stay on maritime. Do you see from a technical standpoint any limitations on size of vessels, vessel runs? Because two examples. One, and don't ask why, but I study this the kidnapping issues that happen in the Indian Ocean. It's not for the cargo; it's for the crew because the insurance payouts. So you have that issue that could be solved with autonomy. And then you have what's going on now in the Strait of Hormuz. Those could potentially be automated as well to take away risk. Do you eventually see yourself moving into potentially into tanker size?
Yeah, that's a great question. Uh, I think the most candid answer is I don't know. I don't
I
know.
love that.
We're early enough in. I just don't know. I mean, we are more focused right now on let's say smaller scale platforms, and so I just can't see far enough ahead to say if it would make sense for us to enter into that. Now, with that said, I think one key point that I want to clarify is when you think of Hivemind and that AI pilot, we generally think of that as living on top of the underlying, let's say, platform autonomy and automation. And the simple statement is that will vary across every platform. How you either change the actuators, effects, lower level vehicle management, and so forth. We don't try to take control of that. We interface with that. And so that allows us to take the Hivemind pilot and move it across a variety of different lower level platforms and integrate with those rapidly. That's also important because for many of the different classes of platforms that we deploy on, they go through certification. They go through certain standards that have to be set, and we can't reach into that, or else we would undo and invalidate that certification. So we integrate with it, and then we introduce assurance layers in between to make sure that whatever the Hivemind pilot is doing is assured to not cause the lower level system to become unsafe. And so that's sort of how we approach that. And so that means that as we approach new platforms, we're integrating with that lower level, which is one of the reasons we're able to pick and place the Hivemind pilots, lift them to different classes of vehicles and platforms very readily as we interface with that lower level system.
To me, what you're describing is robustness. At the end of the day, you're taking a system and you're making it more robust. You're not cutting any corners. And staying on different types of vehicles before we get to space, you're working on the ALC program with the United States Marine Corps and the H-145 helicopter. So we've got fixed wing, we got helicopters, we've got maritime. Walk us through the helicopter. That's pretty fascinating.
Yeah, it's extremely exciting. We're working with Airbus. We're deploying Hivemind on their Lakota system. This is all part of this problem set that arises out of contested logistics. So being able to take cargo from one place to another, and do so in challenging environments and conditions. This is a great example of where we had not even really worked with helicopters, uncrewed helicopters before. In our early days, we had built quadcopters. Of course, we've deployed on fixed wing, we've deployed on other platforms, but we've not really worked with like full scale uncrewed helicopters before. And we were able to integrate and deploy Hivemind and get to flight tests within 10 weeks, working in that particular effort. Airbus with their Lakota, it's a fantastic platform. The Lakota is mature. It's been used for a long period of time to carry people around. So this was one of the reasons we were able to do this is because they are both a fantastic partner as well as have a great machine vehicle that enabled us to really just focus on how do we integrate Hivemind into their framework and their stack. But yeah, it's a really exciting program that just shows how Hivemind can be applicable to yet another vehicle, yet another mission set, and where autonomy and intelligence again plays a very critical role in this case. Again, moving cargo from one location to another under extremely challenging conditions.
10 weeks that's a sprint. That's not a marathon. It's a sprint. Did you stand up a dedicated engineering team to work directly with Airbus? How were you able to achieve that milestone in 10 weeks?
Well, as I was saying earlier, we kind of hit stride in terms of operationalizing our work and our organization. We spin up project teams or program teams that execute against the effort. So you're going to have engineers combined with experts from a flight test perspective, combined with program managers, and yes, of course, working side by side with Airbus to achieve that. Now, keep in mind that was the first flight. We have been testing and iterating month after month for quite some time thereafter. So it was, I guess, the job just started versus job done, if you will, just the first step. But what that allowed us to do is get to results and outcomes rapidly, learn from that, take the data from that, iterate and improve. And that's a major factor in our ability to create higher and higher performance capabilities, greater and greater levels of assurance and reliability, and similar.
Your strategies resonate because in June 2026, the U.S. Air Force awarded Shield AI production contract to provide the mission autonomy for the Collaborative Combat Aircraft (CCA) program. That was just a month ago. Whatever you're building's working. What are you going to achieve with this program?
Yeah, this is an extremely exciting effort as well. And the Air Force has a vision for these CCAs that are one of leveraging these uncrewed systems as an extension to the human pilot as they operate, supporting them in flight, in missions, sending them out ahead, and similar types of mission sets and strategies. Again, giving us that ability to offset humans, to extend mission impact and effect without putting humans in and at risk. So this is a program where we're deploying our Hivemind AI pilot on board these CCAs that they're collaborating with humans, and again achieving that sort of mission set that puts humans a bit further away from the fight.
You're looking at, say, just use the automotive term, the hybrid. So you have the human pilot, you have the autonomous pilot. Does the human pilot have any control over that autonomous pilot as part of that program? Say, go here, go there, or is that autonomous pilot fully autonomous?
Yeah, that's a great question. I think the way to think about how humans interact and engage with our Hivemind pilot is one of a teammate where you have different levels of control. The system has the capacity to really think for itself and make decisions. But of course, as I said earlier, we want humans to be on the loop. We want humans to have decisive oversight when these systems are asked to do particular things where we need human judgment. But at the same time, you have scenarios like in Ukraine where you're going to have contested environments, you're going to have loss of communications, you're going to have loss of the ability for humans to really interact with these systems. And these systems have to be able to think for themselves during that period of time. Now, you might ask, well, then are they able to achieve the mission outcomes without getting human permission to do that? No, they'll come back and they'll ask for permission and then they'll go pursue the mission set and similar. But the idea here is pretty simple, and that is you have to build these systems to be able to think completely by themselves because they're going into these environments and conditions where it's just not possible for humans to interact with them just from a technology, from a physics perspective. But then when humans are interacting with them, you're not really trying to control everything that they're doing. You're asking them to engage in particular tasks, maybe asking them to do particular behaviors to support a different mission level outcomes. And then the systems themselves are thinking about how to reinforce and achieve that intent and objective. And realistically, in those types of environments and conditions where the environment changes rapidly, where conditions change rapidly, you need to be able to have that onboard intelligence to be able to adapt and be resilient during those periods of time, because humans themselves are facing their own cognitive burden and challenges in those conditions. And so having that intelligence system operate as a teammate, where you're able to task it and ask it to do things, where you're able to have levels of control, where ultimately, if you want to just take complete control of it, of course you can. But being able to adjust on the fly is essential to making these systems operable in these extremely challenging environments.
They're challenging environments, and at some point, I'm not an ethics attorney, but at some point, governments and militaries are going to have to let the AI make the decision, just because where I believe the future of combat is going is part of the CCA program. The Air Force is implementing an autonomy government reference architecture. Talk us through that, please.
Yeah, the autonomy government reference architecture, or AGRA, is this idea that it's possible. It's very similar actually to what I was talking about earlier with Hivemind. It's this idea that it's possible to have a consistent reference architecture for these AI pilots that allows for modularity, that allows for the ability to switch between different types of pilots. And the concept here that the Air Force is putting forward, and it's being adopted more broadly, is that they don't want to have vendor lock-in. They want flexibility, they want transparency, they want modularity, they want to be able to bring in the best of breed, if you will, of AI pilots, the most performant, and not be fundamentally locked into a specific vendor. And it becomes very important when you start to talk about these AI pilots, because the advances in technology and performance change rapidly, improve rapidly. And the ability to have the flexibility to switch between providers, to pick the best provider, and or swap out different components of it, becomes a best case scenario for, let's say, the US citizens, because you have you are not locked into a specific vendor. You are not locked into what they choose to do. You are not locked into necessarily their price point, and you're creating a competitive market where the best capability wins.
I'm just going to do this. No vendor lock-in is awesome, because to me, as a United States citizen taxpayer, I love it because costs can go down. As a pro-technological person and a capitalist, let the best technology win at the end of the day. And if you sit back and you look at this as, oh, okay, I mean, let's just go back to old cartoons, the guys chomping on the cigar. How was this able to be possible? Because I think this requirement is awesome.
Yeah, I think it's a great requirement as well. And particularly as we were building Shield AI, it was the case that the ability to have that flexibility, that modularity baked into it, allows entrance into the market, and you're not being displaced by large incumbents. So it creates, as you just noted, an opportunity for multiple participants to engage. Now, in terms of the no vendor lock-in, this isn't just a US construct. We see it across the globe. This idea of sovereign AI, sovereign autonomy, ownership over data, ownership of that IP, the ability to have that modularity and flexibility in what technology you're creating and how you're deploying it. And again, because every country is going to have different ways that they want to use it and different standards and expectations and requirements. That's something that we see at a global level as just incredibly important. And you can really see that within the context of these software-defined systems and the way that you build the brain for these systems, the intelligence for them, because the technology is moving so quickly. If you were locked in, you could get caught in a scenario where you're just working with systems that are not as intelligent, not as capable. And in the future, the future fight is an autonomous fight. It is driven by the pace and the level of intelligence of those systems. So it's a critical objective and critical requirement at a global scale.
Well said. The company Shield has taken I'll call it a platform agnostic approach to autonomy. Why was that implemented early on? Was that the business side saying, okay, technologists, we're going to be platform agnostic. We're going to build a big business here. Why was that decision made?
That decision was made because of the recognition that many different platforms are required and produced and necessary to achieve mission outcomes. And if you try to lock into specific platforms, that's just not going to work for different customers and different needs. And you have huge changes across platforms due to size, weight, and power constraints, sensing capabilities, just the nature of the platforms themselves. So from the very beginning, we were platform agnostic. We were mission agnostic and domain agnostic in the sense that we designed the autonomy framework and infrastructure to accommodate adaptation. And the architecture around that and our ability to do that really came from that work that I had done well before Shield AI existed, where I had to take that and do that and apply that across different domains, across different platforms and vehicles and sensors and so forth. And so it was very clear that it is not just possible, but absolutely necessary from a technology perspective to architect and design for that. And then it becomes essential from a business lens because different countries have different needs, different customers, different mission sets want and have different requirements. And we need to have the flexibility to adapt to those in order to be able to make the outcomes and the impact that we sought to achieve.
You're achieving big things here on Earth, but you're also expanding into space. What are you hoping to accomplish as you expand into space?
I mean, there are many similarities. So first, as I said earlier, very early innings as we grow into space. So I'm not going to be able to talk to the same level of fidelity as even maritime, but there are many areas where autonomy plays an important role in terms of coordination of systems and collaboration, and the same concepts of resilience apply. And so we're engaged with a number of partners and working with them to deploy Hivemind onto those systems. We're not yet in space on an actual platform, but that's not too far off. And so I'll leave it at that. But we're moving quickly to getting outcomes and results and bringing Hivemind to space, which I think is a really great next step for us.
I know it's early innings, and if you can't answer, that's fine. When you look at space, are you looking at it from civilian applications or for military applications?
We're looking at it from the defense lens.
Something big going on. If you go back to Reagan with the Star Wars program and you see President Trump's ambitions for space and you look at the enthusiasm in the stock market for space, I would say it's a very good signal there. Nate, as we look to wrap up this insightful conversation, one last one for you. High level, big picture. What is the future of Shield AI?
I would look at the future of Shield AI as a very deliberate and focused development of platforms where we're bringing particular capabilities like our XBAT as our next platform to market, where intelligence creates a definitive impact on the ability and the success of the mission sets that those platforms seek to achieve. And so from a platform and a vehicle lens, you'll see a next generation aerospace and defense company that's really creating these software defined capabilities and continuing to stay very focused on how we can bring AI, robotics, next generation platform development to the mission. I would say on the Hivemind side, what you'll see is just increasingly sophisticated intelligence capabilities being applied across, again, domains, platforms, mission sets, as we scale and deploy both within the US and globally, with step changes in intelligence and capability on a very regular basis.
I got one more because you said it, the XBAT, and I want to highlight this because on the marketing team, this was brilliant. XBAT, the world's first AI-powered VTOL fighter jet, no runway required. I love the tagline. You're the technical, sir. You're the CTO. Okay, great tagline. How is that technically possible?
So first off, I think it's a great tagline as well. We have an incredible team, and we have a team of engineers that are doing a fantastic job. We're actually going to be going through initial first flight and tests at the end of this year and early next year, so early 2027, in sort of like a scaled down version for first what's called the hopper, our first test of flight. How is it possible? I think if you look at what SpaceX has done with their rockets, if you look at even many, many years ago, there were effectively VTOL platforms and vehicles that were developed many years ago. It was too hard for humans to pilot and take off and land. It just wasn't easy for them to do. But now we have this AI pilot, so it's a great matchup. And in terms of why it makes sense, I mean, the reality is runways are one of the first things to go, and to be able to deploy aircraft carriers with basically this moving city of people with planes on board and bring them close enough to the fight you create an incredible amount of risk. Creating a system that is mobile, that takes off and lands on a launch recovery vehicle, that is able to be rapidly deployed from a variety of different locations without reliance on runway, all from a mission impact perspective, makes a lot of sense. And so we have sort of like the combination of an incredible team that's capable of creating this platform that's able to achieve these outcomes, the AI pilot and the team building that and bringing that together, and that's how we're able to build it.
Let's summarize it this way. That's a game changer. Shield AI is building the future of defense applications. The future is bright. The future autonomous. The future is Shield AI. Nate, thank you so much for coming on the road to autonomy, and I can't wait to see what Shield AI builds next.
Great. Thank you for having me today.
Billions and soon trillions in value will be created in the autonomy economy. By the time a trend becomes consensus, the alpha is already gone. The gap between uncovering signals and reading headlines is widening fast. When it's a headline, it's no longer a signal. Enter Autonomy AI. We decode signals before they move markets, giving you conviction in the autonomy economy. Autonomy AI. Your models, our intelligence. Visit AUTNMY.ai.